Hello everyone and welcome to Introduction to Kinect. Now in this lesson I'm going to introduce you how to develop for Kinect or develop against Kinect. Now in order to do that you really need to install first your Kinect SDK and the Kinect toolkit. And please, if you have purchased, for example, let's say Kinect for Windows, which we are actually going to be working with throughout this lesson, at least this series or this lesson, we're going to be working with Kinect for Windows. We're not going to work with Kinect for Xbox. Kinect for Xbox is licensed for making games for Xbox. If you would like to create applications that users would interact with, that's not Xbox applications or games, then you have to purchase Kinect for Windows. And there are several reasons for that. This is because Kinect for Windows has the seeded mode, and it has not actually seeded mode, the near mode, where you can actually get quite close to the Kinect and still can detect you. As far as I remember, the minimum distance is like without the near mode activated, it's like 80 centimeters or so. And once you activate the near mode, you can actually go up close to Kinect, as close as I think 30 centimeters to 25 centimeters, which is really close. So basically we're going to be working with Kinect for Windows. Now once you purchase Kinect, do not plug it into your PC. You actually install the toolkit. You first install the SDK, then you install the Kinect toolkit, and then after you install those two, you plug it in your Kinect. It will be installed. All your drivers are going to be installed for it, and then you should have a USB audio, because Kinect has, as you already have in the PowerPoint slides on DL system, you have Kinect has already an array of microphones, 4 microphones to be exact. So to pinpoint your location at to pinpoint your audio location, your location audio-wise, and it can recognize the audio much better that way. And you have, of course, this series of cameras which you have, or 2 cameras and the infrared projector. All right. So as you can see, I started with Windows Forms application. I call it the first Kinect app. And a lot of people on the internet, they prefer more to use WPF. WPF is quite easier to use when you would like to decode the series of images which you get, the stream which you get from Kinect. However, I'm not actually going to use WPF. I'm going to show you even how this can be managed through Windows Forms, and this is only just for decoding part, like getting the stream out of the Kinect. There are many libraries that can help you. I'm going to show you one, but I'm saying that regarding not only decoding the streaming, but regarding, for example, skeleton tracking and all these things, for example, skeleton tracking, depth recognition, and all these things, all of this code is exactly the same. The only difference is going to be most probably with how we actually decode the image from the Kinect and put that stream of bytes onto our screen so you can see the video feed. All right. So I will go ahead and expand this form a bit. I will, just for starters, I will put a button over here, and I'm going to hit F4 on it. And let me drag it inside here, so it will be a lot easier for me to manage, and I don't need the Team Foundation nor the notification for now. And I need just only the properties in the Solution Explorer. All right, and this is going to be BTN stream. I'm going to enter, and this is going to be my stream. All right. So here's the little thing which we're going to do. I'm going to actually use that button as a switch. So whenever I press the stream, this is going to be converted into a stop. So whenever I hit the stop button, it will actually stop the Kinect, shut it down appropriately. It's always advised, it is actually advised that you really close the Kinect after you shut it down after you use it, because you could actually leave the Kinect in a certain state which you don't want it to happen, in fact. So technically speaking, please always, whenever you close the application, you have to actually shut down the Kinect, or shut down the stream, or turn off the things which you were monitoring for now. And it's really one line of code, so you're going to see that later. And I'm going to put here a couple labels just as an indicator for what we are doing, so we're going to have a feeling for it. But before I do that, I would like to add an anchor over here, so my button will be anchored all the time whenever I actually expand this thing. And I will push this label. The first label is going to be LBL status, and this is the string, sorry about that. Actually going to be status. Anyway, I'm not going to chain that guy. I'll just put status, colon, enter, and this is going to be the connection ID. All tutorials on the internet, they've done that. I think it's a good idea to keep track of these stuff because sometimes it's good for debugging purposes. Of course, you shouldn't leave this out for the end user, but I'm just going to leave it there just to have some sort of point of reference. And let me push this guy over here, push this guy over there, and I'll have the text to be dash, and here I'm going to have LBL status, because since I'm going to access it through code, and this guy is going to be dash as well, and this is going to be LBL connection ID. Alright, now I'm going to grab my toolbox, just resize the window back, and I'll grab my picture box, because this is where all the streaming is going to come out from. So I'm just going to grab this. I'll try to resize it as much as I can. Now, this guy is going to be anchored from all around, I think. So let me anchor all of these sides, and then when I resize, it actually resizes along with me. So it's going to be, I'm just putting it that I'm spending a little bit of time with the UI just because I need to make it a lot easier for me while debugging. I don't want to be restricted to a certain size. I really would like to be fast. And this is going to be picture box stream and Control S. And the form, I'm going to just rename it to I'm going to call this Kinect feed or Kinect stream, for example. And I'm going to go to my Solution Explorer, rename this. I'm going to call this FRM Kinect. And yes, please rename the class. Alrighty. So whenever I double click on the stream, I would like to start streaming from the Kinect. Now, first, couple of things we need to add. First of all, after you install the Kinect, after you install the SDK and the toolkit and everything, you go ahead and you start with getting the Kinect library, importing it or adding it into my usings. So I'm going to add it here into my references, and I'm going to go here using Microsoft.Kinect. And right now here we're going to have to specify a very simple private object, which is going to be Kinect sensor K-sensor. And this is, in fact, the object which you're going to be dealing with. This is your Kinect, all right, which we're going to refer to it in a minute. Now, as I already told you, we're going to be we're going to make this button as like a switch. So I'm going to have here if btn stream.text equals stream, then I really would like to stream. And here's the point where I'm going to actually start getting the actual sensor. So first of all, we need to check if, in fact, Kinect is connected. So if Kinect is connected, we check it out like that. So say Kinect sensor dot Kinect sensors, which is a collection of Kinects, because you can actually program against multiple Kinects. By the way, you can have hook up 2 or 3 or 4 Kinects. I don't know how many, honestly, but basically you can hook up more than one. Now, dot count larger than 0, and go ahead here. If the amount of Kinects has been connected is larger than 0, that means that there is a Kinect is connected. And since I'm actually programming against only one, I'm going to be only grabbing the one which I need. So I'm going to go here and say K sensor equals to Kinect sensor dot Kinect sensors of 0, because anyway it's a collection. It's in fact a collection of Kinect sensors. So I just simply grabbed only the first one. All right. Now, what I'm going to do here is subscribe for an event when the status of the Kinect has been changed. So I say ksensor dot actually Kinect sensor dot Kinect sensors dot, and then we're going to have here status changed plus equals, and then I'll hit the tab and hit another tab to insert the event handler. All right, so right here when the status is changed, all right, so I'm handling this is an event for Kinect. I'm just, by the way, this, what you see, this line of code, you have been always seeing it from controls right here. By the way, Kinect has as well a list of those, but because Kinect is not a control over here, so you cannot see those. However, if I double click over here, and sorry, if I we grab designer.cs, you're gonna see in the generated code that this line of code, that event handler which I've written, is exactly the same as this one. There you go. You see this one? Exactly the same one. I mean, almost exactly the same one. You see, this is the same line of code, but I just, instead of writing it there, I've written it here. All right, and of course I cannot write it there because Windows is keeping overriding this class, so I shouldn't actually edit it. Okay, so here I'm gonna start handling what happens when in fact the status is changed. So whenever the status is changed, I will just simply say this.lbl status.text equals Kinect. Well, there are two ways of doing this. I can say Kinect sensor dot Kinect sensors of 0 and get the status, or I can just simply say ksensor dot status, and it will give you a Kinect status. It's actually, I think it's yeah, Kinect status anyway. And here I'm gonna have to string. So I just need to let me see here. I just want to confirm for a minute here. F12. Yeah, it's an enumeration. It's an enumeration. So there you go. You have undefined, disconnected, connected, initializing error, not powered, not ready, device not genuine, device not supported, insufficient bandwidth. So you have all those. All right. By the way, I was digging around with hitting F12. So I grabbed, I put my cursor in, not the mouse cursor, but the cursor of the text in the place where I would like to track, and then I'll just simply say F12 to go to definition. Then if I go here, I say F12, I go to definition. All right, so this is going to be to string, and I'm going to add, and then I'm going to actually start the Kinect itself after this if statement. So I'm just going to go over here and say ksensor.start. And I'm going to change this, not LBL, I'm going to say LBL connection ID dot text. I'm going to change the connection ID to the ksensor dot device connection ID. So yeah, so without adding anything anymore, I'll just hit Control F5 and let's see what's going to happen. So I'm going to, oh, before I do that, I forgot to say where to stop. Else, and right here I'm just going to say if the ksensor doesn't equal to null. First of all, we have to make sure this, and the ksensor is running, so the Kinect is in fact running. Then what I'm going to do is a couple of things. First of all, ksensor.stop. See, dot stop. So you actually stop the Kinect. The this dot btn stream dot text equals to start or stream. I'm going to keep it stream here, and And I will, in fact, I'll just put this, I'll actually, you know what? Oh, okay, let it be. So I'm gonna put this pb stream dot image equals to null. And I put this here like that. I skipped a little bit ahead, but for example, when we are streaming, you get the video, but I like when I stop, the whole screen is cleared and nothing in there. All right. So this is what I have done. So yeah, I can stop and I can stop it and I can start it, which is good. So if I hit Control F5 and if I hit stream, we will give it a minute, and there you go. As you can see here, I get the connection ID, but you can see that the status has nothing has been in there. If I in fact go ahead and disconnect my Kinect, and it's disconnected, you see, and if I connect it again, initializing, oh sorry about that, and it's connected, as you can see here. Now if I hit the stream, I didn't change it here, so it will be always like that. Whoops, sorry. Okay, let me disconnect it. So right now it's going to be disconnected in a minute, and I will actually close this, and let me set the label first to this dot btn text btn stream dot text equals to stop. Okay, and let me connect the Kinect right now to my PC, plug it in right now, and let me restart later. Sorry about that. I think apparently I have an update which is pending all the time for some reason. Control F5, stream, and let me make this, all right, and disconnect. Let me plug it in again. Restart later. Apparently this happens whenever I plug in the Kinect, and then when I hit the stop, this is it. Of course nothing will happen here because I didn't change apparently I didn't change the physical status of it, but anyway, so I'm gonna close this one. So right now we can actually start and stop the Kinect. Now we would love to stream the color image from the Kinect to us. Alright, so what we need to do is just simply handle that event. So I will go ahead and I'll say ksensor.colorStream. This is the first thing we need to enable it. .enable. And right here I'm going to specify the color image format. And the color image format, you have many of them. You can actually stream the infrared, the Bayer, raw Bayer image. By the way, Bayer, YUV, Bayer is like, as far as I remember, is the one which defines colors according to the real, simulating the real human eye. It's an algorithm for mosaicing. They call it like, because it actually introduces twice more green than other colors, because as our human eyes are actually quite sensitive to green more than any other colors. More than the red and blue, for example. So Bayer actually algorithm relies on that idea, and in order, if you pass an image through a Bayer's image, by the way, through a Bayer processor, you need a demosaicing algorithm to restore the image back again. It's a very interesting image compression. Have a look at it on the internet. It's quite exciting algorithm. What we need actually here is all the time keep everything in a very fast, how can I say, manner. So here is 30 FPS, 640 by 480. This is the RGB resolution. This, by the way, is this for Kinect 1.0, which is the first edition, Kinect for Windows. Kinect, the second edition, can actually stream full HD image, which is a huge jump actually in the technology, which is actually great for Microsoft. Yeah, so I actually enabled that. I will, in fact, there are several events I could handle. However, I'm going to handle the ksensor.colorFrameReady plus equals tab. Right now I have added this definition for another method. And right here, I'm gonna define what happens when every time when I get an actual color frame. Now, this is actually quite easy. First, I need to grab every frame, var frame, equals to e.open color image frame. So whenever that frame is ready, just please give it to me. Now, when I'm using, this specifies that you cannot use this kind of code unless you are actually having this object implements, this is an object of a class that implements the iDisposable interface. Because what happens is by the end of this bracket, your object is going to be disposed from the memory. And this is what should happen, that every time you are using a frame, you finish working with it and you delete it from your memory and you move on. All right? So, and this is whatever we're going to do right now is going to happen for every single frame. So, I'm going to go over here. Here you actually start saying create bitmap from sensor, for example, or from feed, whatever. And we assign that to our picture box image. So let me create that function for you, creating a bitmap out of an image, like creating a bitmap out of the sensor. Okay, so I'm gonna have here private void. Actually, not void. I need to return a bitmap. And here I'm going to have here create bitmap from sensor. And right here I'm going to grab a color image frame object, because this is in fact returns me a color image frame, you see. So this is actually an object of a color image frame. And I'm going to call this frame. Okay. Right now I'm gonna, by the way, this image frame which we get is in fact is a read-only thing. You cannot modify it. You have to get it, play with it, display it, and dispose it. It's actually a read-only thing. You cannot modify the raw data directly from the memory. You have to copy it somewhere, play with it, and show it later. Okay, this is what we are doing. So that's why I'm gonna have a var pixel data. Okay, equals to new byte array, and that byte array is going to be of a size frame dot pixel data length. So how many pixels we have in the frame, please create a new byte array with that size. And I'm going to have frame dot copy pixel data to, so I'm copying all the pixel data to my pixel data. All right, that's easy. Right now what we can do is start playing with this image. Now we're going to create a var stride, and stride according to MSDN it tells if the image is actually going from bottom to top or top to bottom, defining actually how the direction of the bytes in the image, if they are actually if the image is actually going from top to bottom, bottom to top. It's quite an interesting topic. Read about it in MSDN. Frame dot width times frame dot bytes per pixel. This is how we calculate this, right? Now we're going to create a BMP frame which is equal to new bitmap. Right now I'm going to create a bitmap with the same frame dot width and a frame dot height, and I'm going to specify the system dot drawing dot imaging I think dot pixel format. I need to specify the pixel format here. Dot format 32 BBP ARGB, which is defining that the last bit in fact is not going to be used. So we are using only the RGB without the alpha. var BMP data. Right now I created the bitmap. The bitmap frame, the thing which I'm going to push into it the data. Here I'm going to create the data. I'm going to have new BMP data is going to be equal to BMP frame dot lock bits. So right now I'm going to lock the bits within that frame. New rectangle, and I have to specify the rectangle. And this is quite interesting. I have to specify it really twice. So I'm going to specify 0, 0, comma, and that means I would like to start drawing within my bitmap. So let's imagine for a second, I created in my memory this container, and now I'm going to actually define where I'm going to draw in this container. When I said from 0, 0, I meant that I'm going to draw starting from there. If I start from somewhere else, if I say I start from the half of the width and the height, for example, I'm going to start right here, for instance. So that's why I'm going to have to specify from 0, 0. That means I'm going to start from the beginning of the frame, from right there, until the end, which is going to be the frame dot width and the frame dot height. Let me collapse this. I don't need it anymore, at least for now. And skip that. So this is my rectangle. This is where I'm going to draw. And right here I'm going to have system drawing image lock mode, and it's going to be right only. And here I'm going to grab the pixel format. It's going to be BMP frame dot pixel format. So I'm getting the pixel format which I've defined in my frame. This is my data. I've defined my object, defined how the data will be laid out inside my frame, and all what I need to do is say system.runtime.interoperability services.marshall.copy, and right here I'm going to copy pixel data, comma 0, comma BMP data dot scan 0, which is going to grab the first pointer, like the pointer to the first pixel in the bitmap, and then please traverse that until you get to the frame dot pixel data length. And right here I'm going to say BMP frame dot unlock the bits. So I will unlock the bits from the system memory. BMP data. And right here I'm just going to simply return the BMP frame. And that's it. Now for those who haven't seen code marshalling before, code marshalling means, you see, C# is a managed code. C# is in fact managed code, and the world inside Windows is completely unmanaged. And the problem with that is when you have unmanaged code, you need to have, if you would like to talk to a system, to the internal parts of your system, you're going to have some sort of equivalent on the other side. For example, let's say you have an integer, for example, in C#, but on the Win32 API C++ side, you don't have, for example, you don't have int, you have a short, for example, and what you would like to do is that you should have a sort of mechanism that converts that int to that short, so you can actually talk to the system. This mechanism, having this conversion in the middle, this is called marshalling. So you are code marshalling. All right. For those who just haven't seen such a line of code before. All right. So this is for that part. Now this is the function is write once, and I don't need to touch it again. All what I need to do is say pb stream.image equals to create bitmap from sensor, and right here I'm gonna just pass my frame, and that's it. Now we are good to go. Now if I hit Control F5 and if I hit the stream button, give it a minute, give it a little bit of while, and okay. Nothing apparently is happening. Maybe I am missing maybe I'm actually missing something here. Okay, let me stop this. Close. Did I forget someone here? So let me see here. So var pixel data, this frame copy pixel data. Okay, then we create the stride, multiplying the width by bytes per pixel, and then we have this BMP frame, bitmap with width and height. Okay, and now I grab the pixel data, starting from the zeroth index, grabbing the scan, pixel data length, unlock the bits, bitmap data, return the frame. So technically this one is working, and then now the B stream image. Did I handle? Well, although I'm 100% sure of this code because I've written it, I've used it so many times, but let us try to get that other library. It's called Coding for Fun, and it's actually online. Coding for Fun. Coding for Fun, toolkit. We need the Kinect, not the WPF, but toolkit for Windows Form. Kinect service, toolkit for Windows Form. I would like to get that. Let me have a look again. Yeah, I'll grab this one. And so I'm gonna install it. Close. So we've got it included. And instead of using this guy, let's hope that it's really not due to that one. But anyway, coding for fun dot Kinect dot inform dot. Oh, actually, it's I forgot. Actually, this is it's actually a bunch of extension classes. Sorry about that. So first of all, I'm gonna have just this using coding for fun Kinect dot Windows Form. Yeah. Now, what I'm gonna do here is grab. I wouldn't actually do all this conversion anymore. I think all what I need to do right now is, in fact, get the pixel data and just simply push him in there. So I have to grab this. Copy pixel data to pixel data, and then I could just simply say, let me comment this. And right there I'm gonna have return pixel data dot as far as I remember bitmap to bitmap. There we go. And here I'm gonna just simply pass in the frame dot width, the frame dot height. This is also another option. Let me see if this should work. Let me see, what did I forget now? Oh yeah, I have to call that function again, right? And just in case, sometimes it happens that you get skipping frames. Kinect sometimes due to your hardware, due to many parameters. Sometimes a frame couldn't be retrieved on time, and you can get a null frame. So in order to escape that, I just simply say if frame doesn't equal to null, then just simply process that frame. Else it will just simply nothing will happen. Actually, it will just simply skip that and goes and gets the next frame. If you would like to go faster, you could say, or not go faster, but you could say also if frame equals to null, then return, and yeah. So I hit Control F5. Let us try again to stream. Let's hope it was actually a mistake. I cannot think that I don't think that it was actually a mistake in the code, but we'll see. Maybe I was missing something. Oh, here I am. Actually, it was a mistake in the code. So this is me actually completely stretched, like so. So yeah, apparently I had a mistake in the code. Instead of having me stretched like that, let me stop. Let me close, and let me go ahead and make this image, well, normal. Let's see what's gonna happen. Apparently I missed something in my parameters somewhere. Weird. Give it a minute, and there we go. So let me stretch that part. So I will show the parts which we need. So yeah. Hello, this is me. Alright, so I'm gonna stop this right there. I don't need it anymore. So what we could do is, in fact, play with this, play with the image a bit, but the problem is, oh, actually, there's no problems. Actually, I could do that. I could, for example, I mean, you can do all sorts of crazy stuff. Like you can have, for example, crazy effect, and then I'm gonna pass here the pixel data and semicolon, and I'm gonna, come on, give me that. I think it was control dot, was it? There we go. And I generate a method that will in fact modify my my pixel data, and it's actually quite easy to do because and it's kind of interesting. What I could do here is say for int I less than pixel data, and I will not say I++, but I will say I plus equals 4, and this is for, I think, let's hope that I actually get this right. I think this is actually for a good reason, because I would like to dot count or dot length. There we go. There is a very good reason for this one, because every pixel is consisting of 4 bytes of data. You get the first byte is like red, as far as actually it's actually BGR. It's reversed, not RGB. It's BGR. So blue first byte, second byte is green, third byte is red, and the fourth byte is the transparency, which we currently don't utilize. So here I could actually do all sorts of fun things. I could, for example, say var r equals to pixel data of I right now, for example. This is actually, no, this is actually B. I will make it small so it will be faster to code. Var g equals to pixel data of I plus 1, right? And var r equals to pixel data of I plus 2, right? And right now you can have, for example, say pixel data of I. Right now you can actually do all sorts of crazy things. You can, for example, say let it be like this. I'm gonna actually invert everything. So I'm gonna put this R. You know what? I'm gonna actually copy this. I'm gonna take this out, paste that. I'm gonna hit equals over here, R semicolon equals to B equals to G. Right now I actually inverse things. Let me see what's gonna happen. Let me see how the stuff will look like. I think we have called it right there. So let me see. And stream. I actually could start processing other things, but let me see how the effect goes. So as you can see right now, I got weird colors, not the normal colors anymore, because I have actually inverted some of the colors. So what you can actually do more is do this. you could grab the R, for example, make it equal to B times 1, or actually 2. And you can grab the G equals to R divided by divided by 0.5, for example. And then you can say that B is going to equal to R times G plus 4, whatever, not 4, but plus B, for example, something like that. And by the way, because all of them are in fact, it's going to result to an integer, so I'm going to actually cause that to a byte, and cause that as well to a byte, because we are working with bytes over here. Wait a second. Start doing this so it will actually make sense to the compiler. So yeah, so we've got that. Now we're gonna get all sorts of crazy things happening. Give it a minute. And as you can see, I got kind of weird, kind of effect. Interesting visual effect. By the way, right now you can utilize statistics subject, that you can actually run some sort of a statistics throughout your pixels. And say, for example, if I have more blues than greens, then I'm going to show something. If I have green than blues, then I will do something else. All the filters in Photoshop actually utilize some sort of a statistical analysis for image processing. Right now, what I'm doing right now is actually the image processing. However, I advise you actually to look at the books. Right now, this is not image processing. This is just I'm actually playing games right now. I'm just simply putting colors around, and I just simply mixed them up, and then ended up with some sort of a rainbow-ish color. As you can see, I get this red behind me, and then yellow right there. Then you get this brown, green, and then you get this I don't know, purple, pinkish kind of thing. So yeah, you get really kind of weird effects here. So anyway, give it a try. You can actually stream. You can do the same things with images. You can actually have a video image, and then you can decode that video, and then you can start playing with these stuff. But anyway, I will actually, because it's 42 minutes mark right now, I'm gonna actually stop right there. And in the next lesson, we're gonna start trying to track a couple of things here. Right? So see you in the next lesson.